Hello and welcome to what should be the third and final tutorial in this series. Why do I think that? Well, we've already done all of the processing steps. The only thing that's really left is to plot the seed-pixel correlation map and the connectivity matrix after we've decided what our regions of interest are or our seeds for the seed-pixel correlation map. A word on what we've done so far before we do that. So if you've been following along, you'll notice that all of the files have been saved on the right and they've been saved to file. Now this may not be a problem for, say, when we only have 3 files. But say we have something like 31 files. Let's take a step further and say each one of these files is a gigabyte large. Then, of course, this starts to get very large very fast. Now, MBE is very well suited to dealing with files that are a gigabyte large and processing them. You just have to have enough RAM. But the storage problem still remains. We're very well aware of this, and we'll have an update in the near future where, for instance, in the bottom here, you'll be able to select to delete all of the input data to this plugin after the output is created. So for instance, with a temporal filter, this is the output, this is the input. Once this gets processed to become this is deleted. Very simple. It'll be more of a proper pipeline then. And of course it'll be under user control, so the user will be able to select and decide which intermediate data is stored in their particular project. Okay, so let us load the seeds. Am I loading the seeds? Yes, I'm loading the seeds. Okay. So these are anatomical coordinates on the right that we've loaded in based on atlas coordinates that we know. We can see that it's in microns. It's centered around bregma that I had previously selected. We notice that some of the seeds are a bit off. This is likely due to the fact that I made a poor decision deciding where bregma is. So we can fix this. Just have to figure out which seed this is. So this is the anterior cingulate. Now if we go to the left anterior cingulate in this over here, we can actually modify this directly. So I'm going to make this 75, so x coordinate, and we'll notice that yes, indeed it has shifted. We should also do this for the left retrosplenial. So I'll do here and just make this negative 75. So everything should be in order now. As much order as we can get it. Right, so the thing to note here, you might be wondering, why does the auto ROI placer and the auto seed placer have 2 different plugins? So the idea behind the seed placer is that it's only one single pixel and the seed is defined as being 1 pixel, so you cannot change that. You can also only change the coordinates on the left here. You cannot change it via the create ROIs, so I'll show you in a second what I mean by that. But in a future update, I am looking at combining these 2. It really doesn't feel nice that they're separate, and they should rather be one combined cohesive plugin with the option to switch between a seed and an ROI. Anyway, let us move on to this SPC map. Over here we can see our seeds again. And over here we can choose which color map we want. And I will start plotting some color maps, some seed-pixel correlation maps. So the thing to notice here is, of course, if we pick 3 files like so, and we've picked all of the regions of interest, if I now say save all SPC maps to file, what it is going to do is produce a seed-pixel correlation map for each 3 of these files and each and every single pixel. So that will be a couple of maps, and I'll run that and show you what it looks like. Oh, and whenever processing actually happens and you're not sure whether something's happening, just move it around, and if you see the not responding, it typically does mean that it is working. Right, so the processing is complete, and if we go to the folder that contains the project, we can see that JPEGs of the different seeds have all been saved. Along with a NumPy array that contains the color map data. And in the future, we'd have it that from this plugin, you can just load this color map directly and then get the seed pixel correlation map up via the app. Okay, so let's also quickly show what the interactive window looks like. So let's pick, say, left v1, m1, and m2, and generate SPC maps from these. Okay. Not taking too long. Right, so here are the 3 maps that we've outputted based on our selection over here for the one video file. What you'll notice maybe immediately is that this gradient that's supposed to stay in the top left, for some reason it does bump up to the top left. This doesn't happen in Ubuntu, but it seems to happen in Windows. We've not been able to figure out why, and yes, all you have to do is wiggle your map and it is in position. So as you can see, if we move the cursor around, we can see exactly what the value is at on a particular pixel. Note, of course, that jet has been used here, and there's a number of color maps to decide. Please note that we actually do not recommend jet, and for various reasons that is covered a bit more in depth in the paper. And we also highly recommend the papers cited in the paper to back up that jet is not considered a very good scale by data scientists. Okay, so you can also click on various regions here, and this will actually recompute the seed pixel map. All of these are also automatically saved to file, so there we can see now we have something else with a different seed location. You can also click change which data you're looking at. So say instead of the concatenated data, we're looking at this, or say this, we can click on the center over here, and now this will create a new window with a new map with the seed placed over there. Of course, global signal regression has been applied here, and again we're using jet. Okay, so next let's look at the auto ROI placer. This is basically exactly the same idea again for AI. The only difference here is that you can actually change how large this is. It doesn't have to be 1 pixel. And there's a difference here in that you actually can shift this to the left. So if we go back to the Create ROI plugin, you'll actually see that all of the ROIs from the Auto ROI Placer has been placed in over here. So what we can then do is click on this guy, move him a bit to the side, and then save it. And we can do that to this one as well, that is a bit off to the side, and then save him as well. And what we should notice then, going back to this, is that sure enough, their new positions have been updated. Note, of course, we can also update the size. So this again, I believe, is the left anterior cingulate. Let's make sure. So left anterior cingulate. If we wanted to make this 2 for whatever reason. Okay, so we have to shift it again to the left. Let's just do that here. Notice all that when we change the values here, we are actually not changing the CSV that's saved to file. So I can go load it back in, and it'll be the old values as it always was. This may be changed. The idea is that the coordinates are supposed to be known, taken from like an anatomical atlas, so they're not supposed to be wrong. So it's supposed to discourage nudging them around. And I suppose it's just nice to be able to immediately revert back to what you had. Anyway, so those are those. Let's move on to the final output visualization, which is right. And as we can see on the right here, we have our coordinates. Let's just scroll down here and choose only the concatenated video. This is the video with all 3 videos concatenated. It's over here. We pick all of our regions of interest. Over here you can again choose your color map. Let's just choose varieties to switch it up a bit. and then we can plot our connectivity matrix. Alright, and here we can see the connectivity matrix that was outputted. This is the varieties color map, which is many data scientists are pretty fond of this for being perceptually sequential, unlike JET. So I'd also intentionally left the seed, which I believe is the retrosplenial on the left, outside of the color map, and this is outside of the region of interest, the left hemisphere here, just to show what happens when you leave it out. And as you can see, everything here is NaN. You'll also notice that the standard deviation is 0 in all of these, and this is simply because it was only a single video was selected. So what would have happened if I, for instance, picked multiple videos? So say I selected all of these at the same time, and now what I'm going to quickly do is head over to, let's pick seismic this time, and replot the connectivity matrix. Right, here's the output, and as you can clearly see, seismic is really well suited to clearly differentiating negative from positive correlation. And again, it's a diverging color map, unlike this one, which is sequential, but it is at least monotomically increasing perceptually from the center towards the blue or towards the red. So next, you might be asking, okay, so what is the standard deviation? What do these values actually mean? So if I quit these, I shall quickly save this matrix to file. Show you that in a second. So what did those standard deviations mean? So I selected these 3 files, which of course created a matrix out of all of these. So what happened was a correlation coefficient was computed for each one of these ROIs, so taking all of the pixel values across all frames for each one of these. This gives you 3 different correlation coefficients for each ROI. Ones that are bigger than 1 pixel, such as this one, are actually averaged over the entire thing. So averaged over these 4 pixels, and then the correlation coefficient taken of that average across all frames to give you 1 correlation coefficient. This is repeated for all 3 of these, and then you take those 3 correlation coefficients and compute the standard deviation of them for each and every single cell in the matrix, and that is the end result. I've also saved the matrix to file, as we can see here. So if I was to open this, we would actually get the values again from the connectivity matrix, as well as the standard deviation, and then in a separate file, just to show you. Okay. And again, future development might have it that you can just import this immediately and then get your connectivity matrix back. And quickly, before time is up, we shall quickly plot BC with the barrel cortex and say M1. Over here, we just pick, again, regions of interest that we want. Also note here that we can also define our own regions of interest that can be any shape, and we'll plot activity here. Right, so this is the activity across frames, and you can see we can navigate through it and explore the data as much as we want. For those 3 ROIs, if those ROIs were not a single pixel, every single value across every single frame would have been averaged over the ROI. And as you should be able to see, at least partially, is a little bit of asynchronous activity between V1 here, BC, and M1. Obviously not the best, as this was a bit of a botched tutorial. But you would see that in okay, over here we see it much, much better. Okay, so this can of course also then be exported. Oh, there's also the view all, which allows you to just immediately center on that. So this can be exported. There's many more advanced options here, but the one I'm going to show you is this one here, exporting to CSV, which is the important one. Probably a good idea to save it back in the project, so we'll just call it quickly test, save it, and sure enough, there is our CSV, and if we open that, we'll have the data, all the data we need to recreate this graph as it was in the paper. Okay, we are out of time. Thank you very much.